We are going to be discussing the tanks, bins, and silos. First, we select Structure Type on the General tab. We will then select either the tank, bin, or silo. As far as ASCE 7 is concerned, all of these utilize the exact same criteria for wind load calculations. The selection will only change which structure name is referenced in the calculation output. We will select Tank. The tank is considered an other structure in ASCE 7. The only MWFRS method for other structures is Chapter 29, and so we will select that method. Similarly, there is only one Components and Cladding method that is used for other structures, and that can be found in Chapter 30, Part 7, and so we select that option for our C&C method. Now we click the Tank tab to begin entering tank dimensions. First, we specify the outer diameter of the tank. Next, we enter the solid height of the cylinder. Click the Help button if you have a tank on legs for a diagram showing the height that is to be entered. Select the enclosure type for the tank. This is similar to the input we used for buildings and is used to develop the internal pressure coefficient that is to be used in the calculations. Select the appropriate roof type from the drop-down. If a domed or conical head is selected, you will also need to specify the height of the head. Next, we specify the roughness of the cylinder surface, which is used to calculate the shape factor for the cylinder. The shape factor is a representation of the wind drag on the surface, where moderately smooth would give the lowest shape factor and very rough would give the highest shape factor. If the tank is elevated and on legs, then check the legs option. Once the leg option is selected, there are several other inputs that are required. The clearance height is the distance from grade to the bottom of the tank floor. The number of legs must be 3 or more. The width of the legs is used for the wind load calculation for wind on the legs. For example, if the legs are a wide flange that is 12-inch deep, we would enter a width of 1 foot. The default is to assume the legs are constructed from a flat structural member, but if the legs were round and had less aerodynamic drag, then you would check the round leg option. Finally, we indicate if the tank is in a group of 3 or more. If the tank is specified as a group, then the center-to-center distance of the tanks is a required input. If we specify a large spacing that is more than 2 times the diameter, then we will get an error message indicating that the tank can be considered as isolated. In this example, the tank diameter is 10 feet, and so if our distance is greater than 20 feet, then the tank can be considered isolated. If the spacing is less than or equal to 1.25 times the diameter, then the group criteria is applied. In our example, this represents 1.25 times a 10-foot diameter, or 12.5 feet. If we enter 12 feet, then the error disappears and the wind loads are calculated using the group criteria. Now what happens when the spacing is between 1.25 and 2 times the diameter? Unfortunately, this creates a rather complicated situation. The ASCE 7 standard indicates that you interpolate between the group loads. We got using 1.25 times the diameter, and the isolated loads we obtained using 2 times the diameter. If we enter a spacing of 13 feet, that represents 1.3 times the diameter, then we will see this message. You might be asking, why doesn't the software just perform this interpolation for you? The reason is that this is a very messy situation with regards to the components and cladding calculations. The components and cladding have completely different figures for the isolated and group arrangements, and there is not a simple interpolation between the two. Now we move on to the C&C tab. We will select the Populate button to automatically create an entry for every zone. Now in the bottom right corner, we will select Perform Analysis. The calculations for the tank for MWFRS as well as C&C can now be reviewed.